Welcome to the Hilti PROFIS Engineering Suite Handrail Fixing Module tutorial. From the Setup screen, click on the Handrail Fixing module. There are two steps to designing handrail fixings in concrete, and we'll go through both of them now. Let's begin with Input Design Parameters, which can be broken down into 5 individual steps. We'll walk through each of these input design parameters in detail, beginning with the application. First, choose the orientation of the handrail fixing. For this design, let's select a handrail connected to the front of a concrete slab. Next, choose whether the handrail will be fixed inside or outside, and set the cladding percentage. For exterior applications, the higher the cladding value, the higher the influence on the wind load. For this design, we'll select an exterior application with 100% cladding. Now, set the geometrical dimensions, the number of spans, the height, and the distance between posts. We've selected multiple posts with a post height of 1100 millimeters and a distance between the posts of 1100 millimeters. We've set the cladding height to 900 millimeters and set the space between the center of the handrail to the top of the cladding at 100 millimeters. Now we'll move on to selecting the post and rail properties. Choose the shape, dimension, and material of the post and the rail. For this design, we'll stick to a pipe-shaped diameter of 42.4 millimeters with a thickness of 3.2 millimeters of steel for both the post and the rail. Now, let's apply the loads. Choose where the handrail will be fixed, and Hilti PROFIS Engineering Suite will automatically apply the loads for your region. For this design, we'll select Fixing in a Private Household. For an exterior installation, you'd set the applicable wind loads based on the location of the construction site. Choose the wind zone based on the given map, and choose Terrain Category 1 for the coast, 2 for the countryside, 3 for the suburbs or industrial estates, and 4 for urban centers. Next, set the altitude to indicate the height above sea level. For this design, we've selected Wind Zone 1, Terrain Category 3, and an altitude of 250 meters. Now, we'll enter the dimensions of the building where the handrail will be installed. In the diagram, Zones A and B are shown, with Zone A subject to higher wind suction loads. Choose the zone where the handrail will be installed. For this design, our building length is set at 12 meters, and the width and height are each set at 10 meters. The handrail is installed 2 meters above the ground and is in Zone A. Enter the weight of the handrail, inclusive of the cladding and flower boxes here. For this design, we set the dead weight at 0.4 kilonewtons per meter. Leave this box checked if there are emergency exits and escape routes. This means wind loads will be combined with horizontal handrail loads. Since this design is for a private household, we can uncheck this option. Now, let's move on to choosing our base material. Choose the strength of concrete from the different options available. For this design, we'll select C2025. Select the concrete slab thickness and the distance between center of the post and the base plate surface. We've chosen 200 millimeters and 55 millimeters, respectively. Finally, it's time to set the base plate. For this design, we'll set the thickness of the base plate to 10 millimeters. Next, we'll change the base plate position so it sits in the middle of the slab. For this design, we'll use an offset of 100 millimeters. Now, we move on to the second step to design handrail fixings in concrete, finding a solution. A valid solution will have an anchor utilization ratio, rail bending ratio, and post bending ratio of less than or equal to 100%. Here you can see our rail bending and post bending ratios meet that criteria, but our anchor utilization ratio is over 100% and needs to be adjusted. There are 2 ways to make that adjustment. The first option is to keep the same anchor and increase the base plate height. We can increase the height of the base plate until the utilization decreases to 100%. The second option is to leave the base plate size alone and look for a more suitable anchor. In the anchor selection window, we can go through each family type and size until we get a result that delivers a utilization of less than or equal to 100%. Or to speed things up, we can use the Calculate All feature to calculate all the anchors that would be acceptable using the same design inputs. In the filter settings, we can choose to show only the anchors which work, and we can show the smallest anchor size in each anchor family. Here we see that HST3R M12 with an embedment depth of 70 mm provides a solution. By clicking on the anchor, we adopt it for design and return to the main window. If you need to adjust the rail or post bending ratios, you can change the dimensions or material in the Profile section. Okay, you're all set. Now print a report to document your anchor design, handrail safety design, and weld design. Thanks for watching. We hope you found this tutorial helpful. For more information, please visit Hilti.com.